whenever you're ready.
Okay, so I'm going to read the question first. The diagram shows a cycle track. The track has two straight sides, each of length 40. So I'm just going to label this one 40 as well, so I know that I've used all the information given. Each end of the track is a semicircle of radius 27. So I've used that as well. In fact, let's label this one. And so far, all my units are in meters, which I'm happy about. The diameter of each wheel of Ian's bike is 590 millimeters. Now, before I read anything else, I'm going to convert that into meters as well, because my units always have to match up. So 590 meters, if I divide that by 10, that will give me centimeters. So that's 59 centimeters. But I want meters, so I'm going to divide that by 100, which is 0.59 meters. And now that's the unit that I'm going to use rather than using this one. Ian is going to ride his bike around the track once, so he wants to go all the way around. Calculate how many complete revolutions, which is the number of circles, each wheel of his bike will make. So the first thing I need to know is actually what the distance of this whole track is. So I know that these two distances together are going to be 80 meters, but I need to work out what these two semicircles are. And actually, because they both have the same radius, together they make up one circle. So to work out the circumference of that whole circle, the diameter is going to be double 27, which is 54 meters. Now, the circumference of this is pi multiplied by diameter, which is pi multiplied by 54, which is 169.6 meters to one decimal place. I'm going to make it really clear that I've rounded my answer at this point, so that if later on my answer is slightly different to the mark scheme, they'll see this because I've rounded my answer here. So now that I know the circumference of the circle, which is these two distances, I need to add on these two lots of 40 so that I've got the whole distance of the track. So the distance of the track is that 169.6 plus two lots of 40, which is 80, which is 249.6 meters, again to one decimal place. Okay, so I've got the distance of the track. Now, because I want to find out how many complete revolutions the wheel is going to travel on this track, I need to know the circumference of this wheel as well. So I've done the track, now I'm going to look at the wheel. Again, I need to work out the circumference of it. I want to know the whole distance around that wheel. So because I already know the diameter, 0.59 meters, I can use this same formula to work out the circumference. So pi times diameter again, which in this case is pi times by 0.59, which is 1.85 meters. And that's the two decimal places. Now, just looking at my numbers so far, they seem to make sense. My wheel has a shorter distance than the whole track, which is what I want because he's obviously traveling around it. So now finally, to work out the complete revolutions, I need to do the whole distance around the track divided by the whole distance around the wheel. So if I do 249.6 divided by 1.85, this gives me 134.6 to one decimal place revolutions. Now, because it says complete revolutions, I haven't quite made it to 135, so I can't round it up to 135, which means the complete circles, the complete revolutions, would be 134.